this episode of Cloud Solution Comparisons, we're going to compare the Google Cloud with other solutions. And perhaps I'm going to go a little bit more into detail in this episode, so you get a better understanding of a little bit depth of the technical comparisons. We also have a new format, which is going to be remote and not on site. Therefore, it's very easy to superimpose the slides. Starting off with the same format, the Google history. It was founded by yet another Stanford PhD. Stanford is one of my favorite universities. You have a lot of good technologies coming out of that university. The most recent one is the Stellar Lumens. Jed McCaleb was basically the creator of Stellar, and he also had a large contribution to Ripple, which he left the project because of being very bank manipulated or controlled. But that's a different story. Going back to Google, from the beginning they focused on complex algorithms, i.e. search engines. So they didn't have a marketing gimmick to be able to sell Google like Microsoft did or Facebook did. They actually started off with a university project and research and development on the search engines, that it became a product. They made the largest contribution to internet literacy and making knowledge available in many formats, which was then marketing names such as Google Docs, Google Sheets, and Slides. And the Google or the internet is allowing people to search for the information that they want and expand their literacies depending on what they're looking for. And this was not available 20, 30 years ago. You had to go to many libraries, search for the books to be able to find a particular subject that you're interested in and expand on it. Now, when it goes to the Google business model, they don't have any set marketing strategy. They focus on complicated technology that cannot have that many competitions. So what they focus is the quality of the technology they have, and it's so complicated or complex that its superiority is basically the marketing. So the better they do on their search engines, the better they do on artificial intelligence. Well, that will be itself marketing. They perhaps had tried to have some sort of marketing strategies to compete with inferior technologies such as Facebook or Microsoft, but it didn't even work out because it's just not their type, such as G+ that they shut down just recently. But you can see how more successful they are with YouTube, as that is basically shows the freedom of general public to be able to express themselves, exactly the same as this video that you're watching now. So they are very product focused and let the product speak for itself. Despite the common belief and mediocre statistics, Facebook is not worthy competitor to Google from technological level. That's self-explanatory because Facebook might have some sort of analytics and search engine behind it, but the product that speaks for Facebook is not about the intelligence, or it's not about sophisticated algorithms. It's about how to manipulate the public through the gossip and the social media, but not the positive aspect of it. Therefore, it's not a fair competitor when you want to compare it with products that Apple is offering or Google is offering. They are completely in a different class in comparison to Facebook. Is more of a sort of Microsoft model that focuses, as a matter of fact, on the society's naivety and uneducated aspect of the market. I mean, Google have been having common issues such as antitrust, tax evasion issues, similar to Amazon. But I find them a lot more legitimate than Facebook or Microsoft, as their sole objective is not profit at any cost. So even if they fall into those traps, it's just very hard to avoid, and it is difficult to separate these mega corporations from each other. So after all that, we come to the actual Google Cloud. And purely speaking about the Google Cloud, when it comes to cloud services, they are not quite user-friendly as Amazon Web Services. I've worked with Google products on the cloud, and for me, it was very easy to use. It was very user-friendly, but I come from a infrastructure in-depth analysis and construction of complicated systems. And compared to that, it's easier. But when you compare it to the Amazon Web Services, it's not quite as easy. So you must have an SME on board if you choose the Google Cloud. And also all the services that are available on AWS are also available on Google, but not as many choices of simplification of their microservices. So, for instance, when it comes to the infrastructure as a service or platform as a service, AWS has a lot more to offer, and the microservices as well. But Google is also changing day by day. If they focus on the services to be more simplified for the client, I mean, they have the capability of doing it if they choose to do so. Now we're going to do some comparison from a more economical perspective. Market share among the major clouds, expecting share gains from GCP. So you can here see that you have AWS, Microsoft Azure, and the GCP, and the comparisons between the 2015 to 2020. And as you can see, a big chunk of AWS has been taken away, and GCP is taking a big chunk as well, progressively, although Microsoft has a little bit larger chunk. But that's there is not because of the technical sophistication reasons that they do that. Microsoft always focuses on numbers and shares and manipulations to be able to expand their territories. Now, infrastructure as a service and platform as a service market, again, sourced from Jefferies. We can see the comparison here. The cloud vendors, you got annualized revenue, percent of the market, and year-over-year growth. Amazon Web Services at number one is taking 42% of year-over-year growth, having 51% of the market. And at the second place is Microsoft Azure, taking 17%, which is minute in comparison. Then, surprisingly, IBM Cloud is in the number 4 at 11%. Then Google Cloud is following it at 6%. But when you look at the year-over-year growth, you can see that Google Cloud is gaining a lot. Now, when it comes to a little bit more technical detail, as I mentioned, you have here the service category, the service and the comparison of the AWS with Google Cloud Platform, because that was our intention here. So basically, in this case, you have 4 different categories: compute, network, storage, and database. And in the compute, you have information as a service. So you have Amazon Elastic Compute Cloud compared to Compute Engine. And these are the names that they choose. One can say it's a marketing strategy to be able to replace the names. And you have platform as a service, AWS Elastic Beanstalk compared to App Engine. You have the containers, Amazon Elastic Container Service compared to Google Kubernetes Engine. And Google is actually using the Kubernetes, which is the actual technical containers platform. But Amazon has changed that name, although even under the Kubernetes, you have the Docker. So the Kubernetes is actually built upon the Docker services from a container perspective. Then you have virtual networks, and Amazon Virtual Private Cloud, which is a VPC. And within the VPC, you actually can construct the whole infrastructure. So you can think of it as a data center. You have one data center and another data center. It can be two different VPCs connecting with each other. I've covered this very much in detail in one of my lectures that can be also found in my YouTube clips. So Google Cloud calls it virtual private cloud. Then you have load balancers, elastic load balancer. You got a cloud load balancer on the Google Cloud side. And these load balancers again work at different levels. I explained them in very much detail again in the same clips, so you can refer back to them if you wish to do so. Then you have dedicated interconnects. So you have direct connect and AWS. Then you have cloud interconnect on the Google platform. Then you have domain and DNS. On Amazon, it's called Route 53, and Google is Domain Cloud DNS. As you can see, Google Cloud sticks to the original terminologies a little bit more than AWS. And AWS is trying to remarket them. But that does not mean they're trying to own it. The open source is still open source in AWS. You can use it as you want. You can run a DNS server on a Linux machine on the AWS and run your own DNS services there. But if you choose to, then you can use Route 53 instead. So when it comes to storage, you have the object storage, which is the Amazon Simple Storage service compared to cloud storage. Then you have the block storage, Amazon Elastic Block Store, and Google calls it persistent disk. And under the block storage, you will have, obviously in the data center, you will have all the different levels that you constructed on real hard disks or storages, storage management, such as VLM, and so on. So these are all managed virtually. Actually, VLM runs on the Linux system as well, so you can manually do that as well if you wish to do so. And then you have reduced availability storage, Amazon S3 standard infrequent access, Amazon S3 on one zone infrequent access. So these are a little bit cheaper storages that you want. For instance, if you have a website, you want to put pictures in there and store them. And Google Cloud calls them cloud storage near line. That goes with the archival storage as well as file storage. And these are a little bit less relevant, but still in some companies they're also necessary. When it comes to databases, relational databases, you have Amazon Relational Database Services running on Oracle, MariaDB, MySQL, and in the cloud, Google Cloud, you have Cloud SQL and Cloud Spanner. And again, if you wish to do so, you can create these databases on individual machines and create it on your own VPC or on the cloud, Google Cloud. So then you have the NoSQL as well as with the key value or indexed. In both cases, you got Amazon DynamoDB, and you got Cloud Firestone, Cloud Bigtable, and also you got Amazon Simple DB. So you can see from a fundamental perspective, they are comparing with each other very well. And quickly, we're going to cover the machines that they have as well. So on the left side, you can see the machine types, and then you have the Google Compute Engine. Then you have AWS EC2 on the very right-hand side. I swapped them around now. So you can have a shared or standard or high memory, high CPU or GPU, SSD storage, and dense storage. And you can see the name and the list of the type of the virtualized machines that you can have. I'm not going to go into through them because it does not have any value. But when you're bringing it up, these references help you to choose your machine with the power that you actually need. Then here you have the object storage, Google Cloud Platform against AWS. You can have hot, cool, cold, archival, and size limit, object limits, and all of them, whatever is available in AWS, you have equivalents of Google Cloud as well. Now, when it comes to network latency, I made a bit of a measurement and comparison here. Being in Europe, I compared to Frankfurt, Germany, which is 13 milliseconds, compared to 12 milliseconds. I mean, 1 millisecond doesn't make that much of a difference, but that fluctuates as well. But when you look at the latencies, left and right, you can see there's not much of an advantage from one to the other. Yes. So the GCP conclusion. GCP is definitely one of the choices for companies who have SMEs on board. And I wouldn't say it's the best choice for technically challenged companies. If you don't have SMEs, if you don't have specialists on the company, and you have some, web developer wants to quickly make a site, AWS is easier to go forward with. But GCP is definitely, it's got a very bright future, and I use it for my own personal or company necessities. We actually build on AWS and GCP and OpenStack, which will be the next clip that I will be covering.